Otherwise, please mute. Okay. So in the last class, we have discussed Compton effect. That is almost completed our derivation. The Compton shift delta lambda is equal to lambda f minus lambda I equal to h by m naught c into 1 minus cos theta, right? 1 minus cos theta. Okay. Here lambda f is the scattered photon wavelength and this is lambda I is the incident photon wavelength. Okay, this is the h is Planck constant and m0 is the rest mass of electron. Okay, this is the light velocity and theta is the scattering angle. Scattering angle means suppose here electron is there, we are incidenting some photon or making collision. This is photon. Okay, after this, after that, this electron is recoiling one direction and this photon is recoiling scattering in other direction. Okay, suppose this is the original path. Original path. The angle between original path and scattered path is the angle theta. That is scattering angle. Okay. The shift is mainly depends on the scattering angle. Okay. Suppose here we will see some special cases. Case one. Okay. Case one. If theta is 0, that means what? Theta is 0 means what? Theta we are taking 0. That means what? What is in our words?
Lambda is also 0, sir.
That is okay.
Action.
What is the meaning by theta is equal to 0? We are taking case 1. That means what? What we can say?
Angle of
Initial
scattering is 0.
Yeah, right. Okay.
Photon is 0.
Yeah, photon scattering is not happening. Okay, it is going original path only. There is no scattering phenomena. There is no scattering effect. Okay, you substitute theta is equal to 0 here. Okay, delta lambda is equal to what? H by
0.
m naught c into 1 minus cos 0 means what? 1, right?
1.
Okay, that means this is 0. Okay, delta lambda is 0. In that case, lambda f is equal to lambda I. Okay, that means there is no energy loss of photon. There is no scattering effect if theta is 0. That scattering angle is 0. Now let's take case 2. Okay, if theta is called 90, if theta is called 90. Okay, just you substitute there. Theta is equal to h by m naught c. Cos theta, cos 90, how much? 0,
1.
right? Cos
0.
90, 1, 0.
No, that value will be getting
Yeah,
answered.
yeah, yeah. Okay, good. Okay, h by m naught c. This is the value. Okay, right? And 90 means it is completely perpendicular to the original path. Okay, that is the 90 degrees. And we will take one more case. Case 3. Theta is equal to 180 degrees. Okay, 180 degrees means what? It is back scattering. Okay, it is back scattering. Again, after hitting this photon here, this electron, it will back scatter. That is 180 degree, right? This total degree is 180, right? So it is back scattering phenomena. Theta is equal to 0 without scattering. This is theta is equal to 180 means back scattering. Okay, that photon will completely reverse back. Okay, back scattering, you can write it down. Okay. So here delta lambda is equal to what is the h by m naught c? Just you substitute value 1 minus cos 180. What is the value? Cos 180? Cos 180. What is the value?
-1.
Yeah,
-1.
very good, very good. Okay, 1 minus of minus, this 1 plus 1. Okay, we will get the value 2h by m naught c. 2h by m naught c. So this is the, if photon is back scattered, we will get the shift this much. Okay, now total our shift will be vary from 0 to 180 degrees, and the yeah, theta, okay, sorry, theta, the shift will be, okay, h 0 to 2 h by m naught c. Okay, in this range only this lambda will change, the energy will change within this range only. Okay, this is the three special cases. When theta is equal to 0, that means no scattering phenomena happens. When theta is equal to 90, the photon is completely travel along perpendicular to the this original path. If theta is equal to 180, that photon will completely scattered backside, backs, that is means back scattering. Okay, that is back scattering. Okay, the value is 2h by m naught c. Only our theta is, we can vary 0 to 180 degrees, and the shift will be 0 to 2h by m naught c. These are Three special cases. Okay, can you do one problem? I will will solve one small example problem. Then suppose after that we'll go to the next topic. Okay, so suppose we'll solve one example problem. Okay, this is also very important. Suppose X-ray photon. Okay, please write down and please solve it. Yeah, very very easy problem. So X-ray photon of wavelength. Wavelength is 0.3 angstrom. 0.3 angstrom is scattered through a angle of is scattered through a angle of 45 through a angle of 45 degrees by loosely bound loosely bound loosely bound electron. Okay, loosely bound electron. Find the wavelength of scattered photon. Find the wavelength of scattered photon. Okay, scattered photon. Okay, what is given here? So here problem is we are incidenting X-ray photon of wavelength 0.3 angstrom. Okay, and this photon is scattered with angle of 45 by loosely bound electron, some electron. Okay, then what is the wavelength of scattered photon? What is given here values? Please read the problem and what is given, what we have to find. What is given in the problem? Hello?
Incident wavelength.
Yeah, incident wavelength is given, that is lambda I, that is 0.3 angstrom, right? So, and what is given next? Theta, scattering angle is given 45 degrees. Then what we have to find?
Lambda F.
Lambda F, scattered photon wavelength. Okay, you know formula lambda, you can write lambda F minus lambda I. Sorry, what I'm that. Okay, lambda F minus lambda I is equal H by M naught C 1 minus cos theta. Okay, then you simply substitute this theta here and uh, 0.3 lambda I value you substitute here and you will get the lambda F. Can you do it this one at home? Very, very simple.
Yes.
Yeah, very simple. Just you know lambda I value and you know theta value. Just substitute that values and you find out lambda F. Then you will know how much. After that you can estimate, you know lambda F, right? From there you can estimate E also. E means HC by lambda. Okay, lambda F. This is EF, and initially you can find out EC also. EI also. That is HC by lambda I. Okay, from there you can note, you can observe how much energy lost in this collision. Okay, how much photon energy lost in this collision you can observe. Okay, how much wavelength shift is you can observe in this. After solving you can see that clearly. Okay, how much energy is losing, how much frequency is changing, you can find out. Okay, first you find out lambda F. After that EI and EF you find out. You once you know lambda I and lambda F, you can see the how much wavelength is shifty you observe. Okay, if you know EI and EF, you can understand in terms of energy, how much energy lost in this collision process. Okay, this you can do it after class or when you get free time, just you do this problem. Okay, is this clear problem? You can solve it, right? Just you see the answer, how much energy is losing in this process. Okay,